Now, what is the Lamins theorem? For the Lamins theorem, basically the three forces are required. There are certain conditions for the Lamins theorem that a body must be in equilibrium. There are certain conditions that a body must be in equilibrium. Then next condition is that the forces should be coplanar and concurrent. So coplanar concurrent forces are required. Three coplanar concurrent forces are required. After that, they should meet at the point or they should go away from the point. Okay, means the same thing is that they should be concurrent. Okay, so these are the two conditions. If these two conditions are satisfied, then only we can use the Lamins theorem. But what is the Lamins theorem? Lamins theorem is nothing but the advanced version of the your sine rule. Okay, we have seen it in our previous lectures. So today we are going to learn about the Lamins theorem. What is Lamins theorem? Three forces are there. Let us assume that three forces are there, which are going away from the point. So these are now concurrent coplanar forces. Okay, and its values, that is the magnitudes, are given here. P is equal to, Q is equal to, and R is equal to. Let us assume that some values are given and some angles are given. Okay, so let us assume that some angles are given, alpha, then beta, and gamma. Then what is the Lamins theorem? That if three coplanar concurrent forces acting at a point are in equilibrium, means if it satisfies these two conditions, that the forces should be in equilibrium, these three forces are in equilibrium, and the three forces are coplanar and concurrent, then each force will be proportional to the sine of the angle between the other two forces. Each force will be proportional to the sine of the angle between two other forces. So this is the statement of Lamins theorem, that each force will be proportional to the sine of the angle between other two forces. Sine of the angle between the other two forces. So this is the short statement of the Lamins theorem. Okay, so therefore from this statement what we can write is that P divided by sine of alpha, P divided by sine of alpha, Q divided by sine of beta, and R divided by sine of gamma. Okay, so these things we can write here. P divided by sine of alpha, Q divided by sine of beta, and R divided by sine of gamma. So this thing we can write as from the statement of the Lamins theorem. From the statement of the Lamins theorem. Okay. So therefore, I hope that you have understood what is the statement of the Lamins theorem and how we can apply this statement to the three forces which are concurrent in nature and which are coplanar in nature. Okay, so this is nothing but the outcome of the sine rule. So that sine rule also we have studied, that the three forces are there which has been represented by the three sides of the triangle, which has been represented by the three sides of the triangle. And if these angles are given alpha, then beta, and then gamma. Okay, then how we can write this? For sine rule, so P divided by sine of gamma here, Q divided by sine of alpha, sine of opposite angle, sine of alpha, R divided by sine of beta. r divided by sine of beta. So this will be the statement for the sine rule, which is similar as compared to the Lamins theorem. Only the thing is that here the triangle is there, and in Lamins theorem, the three concurrent coplanar forces are there. Here also, the forces are concurrent and coplanar in triangle also. Only the difference is that the three forces are represented by the three sides of the triangle, and here three forces are represented by the three concurrent coplanar forces. Okay, so this is used in the equilibrium to solve the unknown forces. Okay, if you know the two forces Q and R, and if you know the three angles alpha, beta, and gamma, then you will come to know you will find the unknown force, which is P. Okay, here also, if you know the Q and R, if you know alpha, beta, and gamma, then you can find the P. Okay, in some cases, you can also find the two unknowns if the two angles are same. Okay, so in this way, this Leibniz theorem is used as a shortcut to solve the numericals of equilibrium in which three concurrent coplanar forces are there specifically. In any numerical, if you find the three forces are there, such like this, and three angles are given, okay, in which they ask you to find one unknown force, then definitely you can understand that this numerical is based on the Lamins theorem. Okay, and if triangle is there, then this numerical is based on the sine rule. Okay, and you can apply the simple equation for sine rule. You can apply this equation, and for triangle you can apply this equation. Okay, so once again I will tell you this equation, that P divided by sine of alpha, that force divided by the sine of opposite angle, sine of alpha, then Q divided by sine of beta, Q divided by sine of beta, which is opposite angle, then R divided by sine of gamma, R divided by sine of gamma, which is opposite angle. Okay, so let's move further. We'll solve some numerical. Okay, so here we'll try to solve one numerical. Now here you are able to calculate the angles here. I have shown you how to calculate the angles by using the property of opposite angles. This 30 degree will be equivalent to this 30 degree. This 45 degree will be equivalent to this 45 degree. Okay. And this total is 180 degree. This half is 90 degree. This half is 90 degree. So 90 plus 30, this will be 120 degree. This 90 plus 45 will be 135 degree. Okay. And you have to find the tension in two chains. That is T1 and T2 you have to find. You have to find the T1 and T2 here. T1 and T2. That is tension 1 and tension 2. And you have been given this diagram. You have been given this diagram itself in your numerical. Okay. Now, one thing note down that 90 plus 30, 120 and 90 plus 45, 135. But this total circle is of 360 degree. Therefore, 360 minus 120 plus 135 will be 105. Will be here 105 degree. This will be your 105 degree. And your 360 degree circle will be completed. Okay. So 105 plus 120 plus 135 will be total 360 degree, means one circle will get completed. Okay. Now, once again, you can draw a simplified diagram. Once again, you can draw a simplified diagram. This one is this. This one is second force. And this one is third force. You can draw a simplified diagram. Okay. This one is T1. This one is T2. This one is T2. And this one is T3. This one is T3. Okay. Now the angles are clearly visible from our previous diagram. That angles we have to also write here. Okay. So the angles are, this one is 105 degree. This angle is 135 degree. And this angle is 120 degree. Okay. Now here you got the all angles. Here you got the all angles. Okay. So this one is the simplified diagram. And you have to find the T1 and T2. So how you can find it? By using the Lamins theorem. You can write it here. By using, in solution you can write, by using the Lamins theorem, we get some equation by using the Lamins theorem, and that equation you can write it here, such as T1 will be equal to T2 will be equal to, and T3 is nothing but, what is the T3? T3 is nothing but 1500. T3 is nothing but 1500 Newton. Okay. This one is T1, T2 and T3. So T1 divided by sine of opposite angle, sine of 135 degree. T1 divided by sine of 135 degree. It has been clearly visible here. Sine of 135 degree. T2 divided by sine of 120 degree, and T3, that is 1500 divided by sine of 105 degree. Okay, so here you are able to got the all these three values here, these three equations, you are able to get it, and you can solve this to find the answer. You are able to find the answer. Now by using your calci, you are able to get the values of T1 and T2, T1 and T2, and these values will be in Newton. Values will be in Newton. After finding out the answer, you can write the answer in the chat box. You can write the answer into chat box. Okay. So in this manner, a Lamins theorem particularly can be used to solve the numericals of the three concurrent forces. Numerical of three concurrent forces. Now we will see one more numerical. Numerical number 2 on the Lamins theorem. Numerical number 2 on Lamins theorem. The previous was numerical number 1 on Lamins theorem, and this one is the numerical number 2. Okay, so a lamp is there in this numerical. One lamp is there, and its weight is W is equal to 5 Newton, which is suspended from a ceiling by a chain, and it is pulled aside by a horizontal cord until the chain makes an angle of 60 degree with the ceiling, and the diagram is also given. Find the tensions in the chain and the cord by applying the Lamins theorem. Now the diagram is also given. See here. One ceiling is there. This is your ceiling, okay, which is at the top. Now one cord is there, such type of. The second cord is there, which is been pulled horizontally, and a lamp is attached, which is going vertically downward, and its weight is 5 Newton. Its weight is 5 Newton, and the angle made by this with the string is 60 degree. It's 60 degree. It is been given in the numerical. It has been given in the numerical. And this angle is your 90 degree. This angle is 90 degree. So therefore, you need to find the tensions in the chain and cord. Tensions in the chain and cord. To find tensions in chain and cord. Tensions in the chain and cord. This thing you have to find. Okay. So in solution, how you can solve this numerical? Okay, you have to redraw this diagram in the solution. Okay, after redrawing this diagram, you just draw one horizontal line. Just draw one horizontal line. Okay. Now, if this is 90 degree, then this will also be 90 degree. Remember this. This will also be 90 degree. Okay. If this is 60 degree, then by using the property of opposite angle, this will also be 60 degree. Okay. So therefore, this okay. Now 60 plus 90, here you will get 60 plus 90, you will get 150 degree. You will get here 150 degree. Okay, so this total will be 150 degree. This one is 90 degree. So therefore, how much will be the remaining? You have to subtract these two values from the 360. You will get the remaining value, which is 120 degree. Which is 120 degree. So now you got the three values. Now you got all the three values. And you are able to put all these three values into the expression of Lamins theorem. Into the expression of Lamins theorem. So therefore, how you can solve this numerical? You can solve this numerical as a homework. You can solve this numerical as a homework because our time limit has ended here. So therefore, solve this numerical as homework by using the Lamins theorem. By using the Lamins